This is 9.1a on Laplace transforms. So we're told specifically that we cannot use our table of Laplace transforms for this problem. And we have to use the true definition of a Laplace transform, which is that of an improper integral. So we know that this is the definition of a Laplace transform is an improper integral. So we have the integral from 0 to infinity of e to the negative st times f of t dt. So all we're going to do is we're going to apply this to our function. So our e to the negative 2t. So our Laplace transform of e to the negative 2t should look like the integral from 0 to infinity of e to the negative st, because we still need to carry this with us, times e to the negative 2t dt. So obviously this is an improper integral because you can't have your bound at infinity. So what do we do to make this a proper integral? So if you remember from Calculus 1, I think this is when I learned this, I don't know when you guys did, we're going to take the limit as some variable, I'm going to use t because that's what we're dealing with, goes to infinity, and then we're going to change our bounds to something that looks more okay. And then at the same time, I'm going to combine these two terms since we have the same base and then exponents, we can add them. So we get e, and then I'm going to factor out a negative from both terms. So we get e to the negative t s plus 2, and then dt. So hopefully that made sense. Okay, so now we're actually going to take our integral. Don't drop your limit yet because we haven't applied it. So we have our limit as t approaches infinity, and then times our negative s plus 2, and then times our original function, the negative t s plus 2. And you don't have to worry about your integrating constants. They just kind of make it messy, and they don't really matter for this process. So we have this, and then we're evaluating it at 0 and t. So when you plug in this evaluation, you still have your limit as t approaches infinity. And I'm going to go ahead and pull out this negative 1 over s2. I'm going to have parentheses here. So we have e evaluated at t, so we just leave our negative t here, and then s plus 2, and then we're going to have a minus e to the negative 0 s plus 2. Okay, so this term goes to a negative 1, and we'll apply our limit to see what happens to this term. So now applying our limit, the only t we have left is here. So we have negative 1 over s plus 2 times e to the negative infinity s plus 2, and then minus 1. So hopefully you can see that our negative infinity means we're going to have, something infinitely big on the bottom of our e there. So this term goes to 0. So what we really have is that the Laplace transform of e to the negative 2t equals 1, and then distributing this negative here, 1 over s plus 2. And if you want to check your table, you will see that that is correct. So that is how you use the improper integral format to solve a Laplace transform. And I hope that helped. Let me know if you have any questions.